Hello. Welcome to STG309, case study in how startups like Smartsheet and Quantcast accelerate innovation and growth with Amazon S3. I'm Kevin Stinson, Senior Software Engineer with the Big Data Group at Quantcast.
I'm DJ, I'm a big nerd. Hi.
What you can expect from this part of the session, I'll do a quick overview of Quantcast MapReduce system, and I'll talk about some of the changes we made to move it to Amazon and AWS and Amazon S3, and then talk some of the problems we encountered along the way and what we're doing about them. Now first, a little bit about Quantcast. Quantcast is a leader in digital advertising and audience measurement. We use real-time data about consumer behavior to significantly improve the relevancy of digital advertising. We get over 100 billion bits and process over 40 terabytes of data a day. Our headquarters are in San Francisco, but we have engineers and offices scattered around the globe. We're hiring, so if you're interested, send resumes to reinvent@quantcast.com. Any resume sent to that address will get immediate attention. Now first, a little bit about MapReduce at Quantcast. Quantcast is an open source, I'm going to do that a lot. Too many Q words. QFS is an open source distributed file system that started out life as Cosmic Corporation's KFS, but is now being developed by Quantcast. It's written in C++, but it exposes the Hadoop interface that makes it compatible with Hadoop and Hadoop ecosystem tools. Data written with QFS can be done with replication and ratio coding, and data placement can be affected by tiering and rack awareness. Many of our tools, internal tools and processes expect QFS, and we have more than 17 petabytes of data in our main data system, in our main data center. Now, this basic overview of QFS, it's a lot like Hadoop's HDFS in that there's a meta server which maintains the file system structure and metadata, and chunk servers that actually store the data. QFS client will typically talk to the meta server, which will then tell it which chunk servers to talk to do reads and writes. You can also set up tiering so that data you want to access faster can be put on faster devices to be accessed quickly. Quantflow is Quantcast MapReduce system. We used to use Hadoop, but we found it too slow and inflexible, and we wound up writing our own. And it's the thing that processes the bulk of the 40 petabytes of data that we process daily. Quantflow depends heavily on some of the special features of QFS. For instance, we use a QFS instance tiered with chunk servers with SSDs and RAM disks to hold the intermediate data for the MapReduce jobs. We do have some jobs that temporarily produce more than 130 terabytes of intermediate data. And it comes, we use other things like Zookeeper and Ganglia to help control and monitor the Quantcast jobs and clusters. Now, we wanted to move Quantflow to AWS, both for the excess capacity we needed and for business continuity in case of disaster. So we had to make a few changes to both Quantflow and QFS. We wanted the persistent data in AWS to not depend on instance local storage. So as a version 1.2.0 QFS, we support using S3 as a data bucket. Because S3 is so reliable, we don't support erasure coding or replication to data written to S3. Benchmarks show that QFS over S3 is comparable in performance to other S3-based file systems like EMRFS. But metadata operations such as directory lookups, renames or deletes are quite a bit faster. If you're interested, we have a blog post up on this subject with the results of the benchmark at quantcast.com. And also, it gives you another way to store data on S3 in such a way that standard Hadoop and Hadoop tools can access it. This just shows QFS set up with an S3 bucket. The chunk servers can write the data to a shared S3 bucket. If you have a setup that has just S3 as the only data bucket, then you can set up the chunk servers in special mode that just acts as access proxies. In that case, if the meta server detects that the chunk server is running on the same node as the QFS client, it'll just tell the QFS client to use that chunk server to write all the data to S3. Now, in our data center, we have a lot of dedicated services, or machines running, dedicated service running on dedicated machines for a lot of the auxiliary parts of Quantflow. So to go to package it in AWS, we changed it so that things like the MapReduce workers and some of these services could be easily installed and run on a dedicated EC2 cluster, but we still have some dedicated services running on dedicated instances. Oops, sorry, wrong button. For AWS jobs, the input and output of the jobs are generally to a QFS on S3 instance that holds the bulk of the data that's in S3. We still store the intermediate data on a QFS with chunk servers with tiered RAM disks and SSDs for fast access. We do allow you to directly access the data from our data center, but generally we discourage this because of we're limited by bandwidth and cost concerns. Now, first thing we had to do was copy the bulk of our important data from our data center into the QFS instance S3. This is both to back up the data in case of disaster, and also for input for the AWS Quantflow jobs. It's also made the data available so we could play around with various other services, all the different types of different data flow products without disturbing processing in the data center. We did so distributed copy from one QFS instance to another, and it took us weeks to do it. The major problem is we have a 20 gigabit per second link between the data center and Amazon that was also being used for other purposes, so we had to be careful not to saturate it. And we still copy 120 to 150 terabytes of data a day, keep the QFS and S3 data up to date. Now I'd like to talk about some of the issues we encountered and what we're doing about them. When we first started to run Quantflow jobs in AWS, we found out that the performance was a lot slower than we expected. QFS and S3 performance seemed to hit a cap of 20 to 30 gigabytes a second, and adding more chunk servers and workers doing writes didn't seem to help the performance get any higher. While trying to investigate, we wrote tests that wrote directly to S3, and they had the same issue. Now, we spent a little while trying to figure it out, and then we enlisted the help of some AWS engineers. It still took us 2 months to figure out what the problem was. Somebody noticed that a good portion of the traffic was DNS queries, and that the tests were stalling, waiting for the replies to the queries. We did a benchmark of our DNS server, and we found that it was peaking out about 200 queries per second as opposed to the 100,000 queries per second that we were expecting. As it turns out, as a legacy from our data center setup, we had a dedicated instance running the DNS servers that our AWS setup would all set the machines to use. Unfortunately, this instance turned out to be a T2 micro instance. And because S3 uses short DNS TTLs to do load balancing, the large volume of DNS queries was just overloading the poor little server. So we changed the setup so that DNS queries for the S3 endpoints went directly to Amazon DNS server instead of to this DNS server instance. We immediately achieved 75 gigabytes per second for the type of cluster that is typical of the jobs that we normally run, and a slightly larger cluster of more capable instances could easily hit 100 gigabytes a second. I'm told you're just using Amazon VPC DNS would work too, but we have not tried that yet. Now this just shows the improvement just from making this minor change and how we did DNS queries. This just goes to show that sometimes a minor change can make a big difference in performance. There's a checklist of things to think about for high performance with S3. Use multi-part uploads and use well-distributed object keys, which should allow S3 to do partitioning much better over time. Make sure your DNS capacity is high enough to handle the load of DNS queries. And also pay attention to the instance types you have and make sure that they have enough resources to do the job that's expected of them. Here's a list of some of the tools that we used. We found tools like GPX execution shell are really handy for tests that require running tests with lots of instances all at the same time. Now, we tend to run Quantflow jobs with fairly large clusters, and we wanted to start using spot fleets instead of on-demand instances. But getting a spot of that large a size spot fleet could take a long time, or even be impossible because there's not enough instances available in the fleet. Or in the end, it winds up costing a lot more than you expect. With the changes of pricing and availability, we wanted to be able to get a mixture of different types of spot feet so we can maximize or optimize the price, and also so we can drop and lose instances if the price changes. And we can get another fleet at a better price. However, since we store the intermediate data in instance local storage, this poses a bit of a problem because losing an instance means we might lose the data, and then the jobs would fail. Now, we're experimenting with the workaround for this. The idea is to request smaller, multiple spot fleets, which you can get much more easily and probably for better prices. I mean, you could tell QFS that each fleet is its own virtual rack, and then QFS rack placement will try to spread the data across all the fleets as well as it can. That means with using QFS's standard Reed-Solomon 6.3 erasure coding or using four-way replication, you could afford to lose up to 3 fleets before you run the risk of losing data. However, with erasure coding, it'll take less space, but the extra time and I/O it'll take if it starts doing data recovery, actually start losing instances, we tend to use replication instead. Some parting thoughts. We found that an easily overlooked item of your setup or configuration can have a large impact on performance. As we started to use this, develop this service and also started to use a bunch of other services like Kinesis and Lambda, we also kept on hitting a number of account limitations. If you're lucky, you'll find out that you'll get an error message that'll tell you what the issue is. Otherwise, your performance can also just level off. There are a lot of different account limitations, some of which you would never think of. And there are actually some limitations to the products themselves, such as I believe the delete rate from a bucket in S3 is fixed and isn't changeable. So if you use an AWS services and your performance starts to level off, ask your AWS liaison or customer support person to see if the account issue or even a service limitation might be the issue. And now, I'll pass the clicker over to DJ Hansen from Smartsheet.
I get the power now. Thank you. So before I begin in earnest, I would just do a quick survey so I know who I get to make fun of in the rest of the presentation. Could you just raise your hand, hi sign, if you self-identify as a systems engineer, systems administrator, okay, as DevOps. Now, it's okay to self-identify as more than one thing. So this is Vegas, it's a safe place. There's about, it looks like 4 or 5, as a software developer. Get a lot of software developers, about half the room. Not going to make fun of software developers, good. Architects, about 30 people, that's good, we'll make fun of architects. A product manager, project manager, .star manager, 1. It's going to be uncomfortable, I'm sorry. That's okay, though. So I'm DJ, like I said, I'm from Smartsheet. Y'all don't care about that, though. Y'all care about this, which is figuring out how to turn that software architecture diagram. We all love, that's our standard guy. Shout out to my guys from Lucidchart for their wonderful templates. How to take that diagram and turn it into this diagram, which, okay, cool. That don't look like a whole bunch until you realize that what disappears, those 2 blue jobs right there, those 2 blue guys that disappear, that's your relational data store. And that's something to be excited about there. Now, unless you're one of those people that gets super excited talking about InnoDB page fragmentation patterns or Oracle redo log manipulation, if you are one of those guys, talk to me after. I probably have a job for you. But if you're not one of those guys, if you're like the rest of us, this is a big deal because when you can get rid of that relational data store, all of a sudden, you have a lot more time to invest in other parts of your product, other parts of your operational posture. You don't have to worry about all of that maintenance. You just get to shove it all into S3. S3 is amazing, and it's wonderful, and we love it. Being able to make this transition brings with it a couple of problems that need to be solved that you need to be aware of if you're going to walk away from those relational data stores. There's a reason that design pattern has existed. Now, to understand how we got from slide A to slide B, you need to understand a little bit about our use case and some of the trade-offs that we made. Now, this next slide is my favorite slide in the entire presentation, because this slide lets me expense the whole trip on my marketing department. Thank you, guys. So Smartsheet, we're a collaborative work management platform. It's very sizzle, so hype. I mean, it is really, 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 no, it's a spreadsheet, right? It uses a spreadsheet-like interface. There's a reason for that, which is that spreadsheets are one of the few intuitive ways that non-technical audiences will have confidence that they believe they can manipulate structured data or semi-structured data, right? We're here at the AWS reInvent conference. We know what's up, right? If we need to do a little analysis on data, we spin up a little MySQL node on our desktop or whatever, and we just insert some data and do some selects. And the rest of the world, they're much more comfortable when they get an interface like this. So we take advantage of a lot of those idioms. Now, we wanted to add some additional feature sets to this, right? We do a lot more than just your basic spreadsheet stuff. One of the things that we wanted to do was taking advantage of this quirk of human nature, this nice 40-watt computer that bounces around inside of our skulls. A stunning portion of the neurons in our head are dedicated to the processing of visual information and visual stimuli. We wanted to take advantage of that in our product. We wanted to put images and pictures into that grid interface. And you can just see here in the difference, right? The impact that just those descriptions have isn't necessarily the same as that impact of seeing those pictures. Now, we had a few different design things that we needed to work with, right? We needed to have access control. We needed to have, do rehosting, good net citizenship, that sort of thing. And we also had this other use case where we needed to be able to dynamically resize the columns so that people could make large thumbnails, small thumbnails as they go along, as they're in their view. And we wanted those pictures to grow and expand so that we can take more advantage of that visual space. That is a little bit easier to scan across than that, but that lets you get more data in the screen. We wanted to be able to do that dynamically as we went. So what we realized is that we had to re-implement Imager, right? And so they locked us in a room with a bunch of pizza and a bunch of caffeine. I'm not certain I assume they locked it. We didn't really check, right? Because, you take pizza and caffeine and nerds and whiteboards, that's like nerdvana. That's great stuff there. And so we had to bring our own D20s, right? But that's okay, because I never roll another man's dice anyways, and I'm the dungeon master, so they always want my dice to be as far away from them as possible. 2 weeks later, We walked out of that room very happy, and we walked out of the room with this design. Wait, those blue things are still there. What the heck, DJ? Why are you talking to me about this design that has those relational data stores? I want to get rid of those things. Well, to tell you how we realized this was, we thought this was great. We were proud of this design. We were all happy and just walking down, smiles on our faces. Thought we had something great. And to understand how we came to realize our mistake, I need to tell you a little story, right? Because it's cultural history. And I need to tell you this it's a story in the before times, right? During the way when 2001-ish, when we still built our own data centers like some kind of savages, right? When we ran C and Perl, and we were proud of those languages, right? Performance, expressiveness, oh man, this is the best thing ever, right? 2001, when your killer app on your phone, you remember the days of Snake. I never filled up the screen once. I just wasn't there. I didn't have it. You get the call when you're in the middle of the game. Oh, it was the worst thing ever. You had a really good game going and someone calls you. Oh man. Now, if 2001, to understand this mistake, you need to understand how 2001 the architectural design from 2001 would have looked. And it would have looked a little something like this. This is actually my favorite slide. Our marketing department killed it. When you talk about this slide, in 2001, data went in databases, right? We didn't have S3, right? We didn't have EC2, right? This was ancient dark days. And all your data would have gone in a blob somewhere in some relational data store, right? You might have put it in Oracle, you might have put it in MySQL. If you were really cutting edge and avant-garde, you might have put it in like that Linux and MySQL thing that all the hippies were talking about in the open source space. But that image data would have gone in a blob. And feel free to take it. This slide's going to be up there for a while, so take your pictures because it's great. You'd have put your data in that blob, and you would have been defensive in your design because you do not like being woken up at 3 a.m. because the file system has suddenly decided to fill up. And this is still 2001. We don't have SANs. We don't have robust storage area networks yet, right? We don't have LVM really supported in the Linux kernel yet. Like the concept of resizing a file system was like dark magic that would have never worked and never happened. So you are going to put these limitations around your design. You're going to say, all right, we're not going to store this great 2 meg raw TIFF bitmap that from someone's digital camera. 2 megapixels was a big picture back in the day, right? We're not going to store that. We're going to compress that down a little bit. We're going to limit you to 200K of total image size whatsoever, because the thing that's going to kill you in this design is your storage. Your queries are boring, right? Your queries are just over-glorified indexes trying to find some object key lookup that you get your primary key and you go get your image data from the disk and there you go. Now, when you want to resize it, when you want to do other processing, maybe you want to store it in a different format, et cetera, you're going to, instead of storing all of those images as well, because storage is what kills you, you're going to spend a little bit more time, you're going to buy some more compute resources, and you're going to do the processing just on demand and throw that data away. And that's a good design, right? You do get a couple things for free, right? You're going to get nice metadata, right? You're going to be able to track who's storing your images, who's paying you for them, who can access them, right? You're going to be able to work through those query patterns and get a very good sense of that metadata. It's going to be all joins, and it's going to be done very nicely for free. You get good replication in the Oracle sense. These things are good. So let's bring 2001 sysends guy back into the future with us and see what his reaction would be to our object store. Now, he is going to love S3 eventually, right? If 2001 syseng guy were just brought forward in 2016, he would be staggered at the progress that we'd made. He'd be confused. He'd wonder why we still had Florida. Is there anybody from Florida here? No? One, thank you. I love you, Florida. You make the rest of us look so good by comparison. You never change, Florida. You do you. But 2001 syseng guy would wonder why Florida still hadn't been like covered by a meter of water from oceans rising. He would be stunned at the concept of an endless file system that just doesn't fill up. I mean, you're not going to fill up S3. You might run into your account limit when you try to put a bunch of stuff, but you're not going to fill up S3, right? And I was that caveman, full disclosure, 2003, 2004, whenever it was. I worked at Amazon. I was in infrastructure. And when AWS and EC2 and S3 were just a gleam in Papa Bezos' eye, right? I'm sitting there saying, this is not going to work. Nobody is going to buy a non-atomic file system that you can write and read and get your old data back if you do it fast enough. Nobody's going to do that at web speeds. I mean, the internet still wasn't super, super fast in 2004. They're not going to buy that. Nobody is going to buy S3. Do some back of the envelope math and realize, wait, we're going to charge how much for what? And raw disk cost, wait a second. No, this is going to be a disaster. And I was dead wrong. I was a caveman. And I'm happy to admit that, because S3 has been fantastic because it lets this design exist, which is so fantastic for our caveman, because he's not going to run out of storage. He's not, it just expands. You don't have, nobody talks about a 3 terabyte S3 bucket in the sense that that's the limit on the bucket. Those limits don't exist. It changes the game. And whenever you have game-changing assumptions, something that completely changes this, the unspoken things that we never challenge anymore, because it's just, if you spent your entire life challenging every assumption that came across, you'd never get anything done. You'd just argue endlessly. And again, that's also nerdvana. But you wouldn't get any products built and you wouldn't make any money. Now, 2001, sysadmin guy would still think that the Star Wars prequels were going to be a good idea. So we still really can't trust his opinion. Well, in the end, how do we do it? Let me stop blithering about the past. Let's talk about the future, right? And the way that what we realized was, as we wanted to expand what we were doing, we wanted to sort of cut some costs on what we were doing with EC2 and processing this data. We realized that objects and object paths are not exclusive to each other, right? This is my S3 bucket. This is actually an S3 bucket that was available, and I was so happy that it was available, and it's mine forever, and you can't have it. But that right there is a checksum of a picture of a cat and a walrus. And on that picture, you can see here that when I do that ls, I see a prefix and I see the object. What we wanted to do, and what our use case was, if I sort of drill into that object a little bit, you're going to see that I've got 2 other prefixes, mobile and thumbnails. Underneath the mobile, I've got a couple, I got a JPEG there, right? And then underneath thumbs, I've got some PNGs. What we ran into in our use case was that on our mobile application, when we wanted to put that image in there, we wanted that image to be formatted a little bit differently, right? We wanted that image to be able to zoom and not have the same kind of artifacts. We needed to process this data. And we're trying to make this trade-off between the work it takes to do the CPU processing and getting it out to the user faster. And we're going back and forth about these trade-offs, and finally somebody in the room said, wait, why don't we just shove it in S3? Because S3 is bottomless. You're not going to fill up S3. Just do the work, pay the price once to do the processing at the best quality that you can for the best compression, and then shove it off and store it. And so we did. And then that was really cool. We liked that. We were fans of that. And we said, let's do more. It's like a kid with a new toy. We wanted to just start shoving everything into S3. We started shoving all the widths in S3. What we discovered is that there's a lot of widths that are sort of common, and they fit into different patterns, and that we can pre-process those and store them ahead of time, and life is good for everybody, and there's much rejoicing, and the Monty Python, yay, appears. Now, a couple caveats. When you see that trailing slash, right, Amazon takes advantage of an old POSIX behavior when you talk about that trailing slash. This is a grab from my workstation, bash for life. And what you see here is that if we have 3 files, foo, that are all named by the directories we want to move them into, and I want to move foo.bar into the bar directory, that works just fine. When I want to move foo.baz into the baz directory, I get a little unexpected behavior here, but when I try to move cux into the cux directory, it fails appropriately, saying that cux is not a directory because I have given it the trailing slash. When I'm talking about a trailing slash, I am now explicitly declaring that I'm talking about the directory, that I've identified this as a directory, not just a symbol. And you can see, you look here, now I've got bar, foobar, the thing that I didn't want, and then the failure case that I would expect. Right. This right here is my favorite piece of Linux trivia. If I'm ever in a nerd off and I need to sort of assert dominance in my nerdery, this is sort of one of the places that I'll go to. Oh, what does the trailing slash mean? Yeah, we're going to go to errata and man page trivia. Back to the story. Just be aware when you're operating against prefixes, because there's a little bit, you can get yourself into a bad situation. Here, I'm trying to copy this picture down into my directory, and something weird happens. Who can recognize that MD5 sum? 100 points for anyone in the audience that can recognize. What's that MD5 sum, sir? That's the MD5 sum of nothing. 100 points for the gentleman in the audience right there. That is correct. Now, this is 2001. MD5 sum was still okay, no hash shaming. Okay? But that's an empty picture. That is nothing. I downloaded an empty picture, and it didn't give me an error condition. It just gave me an object that was empty. Here I do the correct thing, omitting the trailing slash, and I get the MD5 sum of my nice picture of the cat playing with the walrus. For some reason, my editorial team at Smartsheet decided that the picture of the cat with the walrus wasn't going to fly. They didn't want me to put that in there, so I can give you the hash of it, though. Congratulations. Enjoy it. It's really cool. Again, as we come in, we drill down. We see that this is a directory. We're going to drill into it. Now, notice this thing that shows up there, that meta.json. We got really excited about what we were going to be doing with this meta.json file. Because we're like, hey, we can just take all this data that exists in this relational ledger, we can shove it all in there. And we started shoving it all in there, and we started testing, and we started doing some of our operational use cases where somebody ceases to be our customer. I don't understand why anybody would ever want to do that. And so we don't want to continue paying for the S3 storage for the thing that they're no longer paying us for, so we want to find that and get rid of it and clean it up. We have data retention policies that we're letting our customers take advantage of, where when they delete their data, we go make sure that their data is deleted on the proper schedules, et cetera. We needed to find this data, and we didn't have that nice data store anymore, and it became a little bit of a problem. This is circa 2012, 2013. Maybe it was 2014. Time flies. So what do? We did some ghetto stuff. We built a binary tree approach that was able to transverse with prefixes, that was able to take some Amazon, the object metadata, and be sort of a delivery node so that we had this list of other object IDs based on paths that were prefixed on the indexes that we wanted to make. And it was clunky and kludgy, but it worked. It was complicated, but it worked. Every developer in their right mind was terrified to go into that code because, yeah, who likes writing binary trees just from scratch? No, that's why we write libraries. So I don't have to do that anymore. Who loves writing linked lists? No. The last linked list that any of us have ever written was in an interview, I'm almost certain. That's my favorite. That's my number one pet peeve on interview questions. Implement a linked list. No. Use list. Import list. That's why we have libraries. And so we started taking advantage of this metadata. We would put things in this metadata that let us do this. Amazon has now changed the game again for us. Who was aware of the announcement to the new feature set in S3 that hit yesterday, like 2 p.m.? Object tagging. Go Google it. It's your best friend. The Google indexes haven't quite caught up to the new documentation yet, so you'll still be talking about sort of bucket tagging or questions from Stack Overflow, or people are saying, I need to index my data, and all of those old solutions and kludges that, nope, stop doing that. Don't listen to Stack Overflow on that. Don't listen to Stack Exchange on that, right? You want to use object tagging. What object tagging gives you is this ability to take these fields. Now, this is not correct because it's not actually metadata fields. I wasn't exactly sure when the embargo would end, so I had to be a little defensive in my slides. But you will find that when you use object tagging, you can now filter your entire bucket based on those 10 searchable fields. And so put data in those fields, and now you have your indexes. And now you get to get rid of that bloody relational data store that just ruins your life all of the time. You can stop waking up at 3 a.m. because replication stopped on the data store. I love RDS, but I don't really love relational data stores. When we deployed this in 2014, we built it on one S3 bucket. We used all the right scaling concerns, prefixing on 2 characters, making sure that we were going to be able to do that searching properly, get the right distribution of the data, et cetera, all those best practices. And the number of times that this thing has woken me up at 3 in the morning or woken someone on my team up at 3 in the morning in the entirety of its existence now has been exactly 0. It's never filled up. It never breaks. We bounce those instances around in that design, as you'd see, so that those instant storage volumes don't fill up. We put the logs up in CloudWatch, and it never, ever wakes me up. It just works. And that's how you know you've got a good abstraction. That's how you know you've hit that sweet spot, where you have something that's totally going to change all of the rules and turn all of us today into cavemen in the future, when those young whippersnappers that are today with the Twitters and the Instagrams and the Growens and we turn into Grandpa Simpson, because what's hip now will change, because they will look at all of these things that we're doing that are just vestigial coming along for the ride. Nobody questioned that relational data store in our design reviews. Nobody. Because we were so used to this world where data goes in databases. Oh, we've got data, put it in a database. And nobody questioned it. And we could have gotten rid of it the whole time. Luckily, we did. 2 quick caveats for you. Consistency is still a thing. And if you need commit, if you need transactions, don't use S3 yet. I can still get into a case where I can do a write to S3, I can do a read somewhere else in the world, get some other set of data. Those updates will come, they will land eventually. But if I'm making further logic decisions based on that particular read that I did, that may not be the reality that had been accepted by the cluster. Just note, there are still a place for relational data stores. If you need to do select, update, update, select, select, update, update, select, select, update, insert, insert, update, delete. 1, you have my pity, because that is painful and it hurts. Commit. Wait, roll back. If you still need to do that, I'm sorry, you're still stuck. You're going to have DBAs, and they're going to have to charge you lots of money to do the thing that you don't want to do, which is deal with this data store and think about all of that InnoDB stuff. You're still going to have to deal with that in S3. But if you can pay the price, if you can walk away from the conceptualization that you have of needing that kind of transactional consistency, you are going to be able to leverage this design. You're going to be able to step away from that relational data store. You're going to be able to just put S3 will be the last database you'll ever need. And you'll start saying, well, where's data? Data goes in S3. Oh, we need to store some data. Good, put it in S3. And it'll be great to get to 20 years in the future when Florida is covered. You can join the rest of us whenever you'd like. Oh. When that happens, and that future arrives, and that future time shows up, we will be able to just know data goes in S3, and that's there. Thank you. We've got to have some extra. I'm going to dispense with some of the extra random trivia that's there. We have some related sessions for you. Quantcast has some other sessions.
Yes. Yeah, if you're interested more about Quantcast experience with other AWS services, check out DAT 310, which is tomorrow at 3:30, I believe. And then also, there's the deep dive in Amazon S3, which is 4 o'clock tomorrow.
I can go on for a while yet. I've got lots of other war stories and whatnot, but my stories are boring and your questions are much more interesting. We do have a mic in the back there, and the session's being recorded, so if you could go to the mic for if you have any questions about anything that we've run into with S3 or other random stuff, or you want to ask me questions about what Amazon was like in 2003, whatever. Those questions will be welcome. We'll be happy to answer them. And we thank you all for coming. Thank you very much.